Okay, when you're faced with a question that asks you to prove something, like this question, okay, it's a trig identity question, you need to know which trig identity you're really looking for. If there is a squared term, and in this case there is, you will be using the trig identity sine squared x plus cos squared x is equal to 1. Now, if there wasn't a squared term, and you've got a sine and a cos, the most likely thing that you will be doing is using the other trig identity, tan x is equal to sine x over cos x. Now, neither of these identities are given to you in the formula booklet. You need to remember them. Okay? Now we're going to use this one to prove that the left-hand side is equal to the right-hand side of the equal sign. Now, rule of thumb with problems like this, start with the most complicated looking side, in which case it's the left-hand side. Now, I've got a sine squared x at the top there, so I'm going to work with that, because I now know from this identity that sine squared x must be equal to 1 take away cos squared x, just by moving that cos squared x over to the other side of the equation. So now my left-hand side becomes 2 take away 1 minus cos squared x, because I've replaced sine squared x with 1 minus cos squared x, all over cos squared x plus 1. Now if I sort the top of that fraction out, the numerator, I've got 2 take away 1 and 2 take away minus cos squared x. So that becomes a plus cos squared x all over cos squared x plus 1. So I've got 2 take away 1 is 1. So on the top I've got 1 plus cos squared x. On the bottom of the fraction I've got 1 plus cos squared x. So that is automatically equal to 1, as required. Okay? So I've shown that left hand side is equal to the right hand side.